Okay, so let's jump into the summary for formulas and equations. So first off, let's think about why do we need to write formulas. The whole purpose is to tell us what's the ratio of atoms or ions that exist within a substance. So let's split them into the three types of bonding: ionic, covalent, and metallic. So first out, for ionic compounds, check that it's an ionic compound in the first place by checking whether is it between a metal and a non-metal. So once you've made sure that it's an ionic compound, then first let's look at how do we get the formula of ions. So we have to first split it into the cation and an anion. The positive ion always comes first. So for the metal cation, right? If it is a transition metal, the charge is actually given in the name. Like say copper bracket 2. This 2 tells us it has an oxidation state or charge of +2. So I will note down here. For the anion, check that what it ends with. If it ends with an IDE, I can look for this particular element within the periodic table. So from the periodic table, I see that chlorine is in group 17 and has the electronic configuration 287. So once again, I know that I need to gain 1 electron to become 288. So it will have a charge of -1. Okay, gaining 1 negative electron makes it more negative, so it is -1. Now that I have written down the formulas of the ions, let's determine the ratio that they must exist in to balance the charges. So recall for ionic bonding, we also talk about balancing the charges when we draw the dot and cross diagram. So here I have the cation is 2+ and the anion is 1-. So for the charges to balance, I need to multiply the anion by 2. So let's write the formula by writing the elements ratio in subscripts behind it. So we know that the ratio is 1:2. So there is an invisible 1 here that doesn't need to be written because there's a default lah. If there's no number following it, we take it as there's only 1. And for chlorine or chloride ion, because there's 2 chloride ion per Cu2+, I need to put a 2 behind Cl, not in front. So this 2 only belongs to Cl. Some things you need to memorize. For the cations, you need to memorize the ammonium cation is NH4+, and this 3 cannot be deduced by looking at periodic table. Okay, and for the anion, these are the polyatomic anions. We have hydroxide, nitrate, carbonate, sulfate, and phosphate. And you see that those that ends with ADE, ATE means that it is that element plus some oxygen atoms. Okay, what do I mean? Say nitrate is nitrogen plus some oxygen. Carbonate is carbon plus some oxygen. Sulfate is sulfur plus some oxygen. And phosphate is phosphorus plus some oxygen. As to the exact number and their charges, this is something you need to memorize. Okay. Next, we move on to covalent molecules. So remember that this bond is formed between 2 non-metals. So first, we can determine the number of atoms of each element based on its suffix in the name. Okay, so say sulfur hexafluoride. There's nothing in front of sulfur, so we take it as the default is 1. And for fluoride, there's this hexa in before that, and hexa, like hexagon, stands for 6. Okay, so here's some of the suffixes and their meaning. So sometimes the mono is written for the second element lah. Say carbon monoxide. So there's 1 carbon and 1 oxygen. Or carbon dioxide means that there's 1 carbon and 2 oxygen. Okay, tetra means 4. Then simply we just write the formula with the elements ratio in subscripts behind it lah. So sulfur, there's nothing written in front of it, and we take it as is 1, right? So we don't need to write down anything. And for hexafluoride, we know that there's 6 fluorine. So it's written behind F lah. Okay. So some things for you to memorize is that there are certain elements that exist as diatomic molecules. So there's hydrogen, if I were to draw out the structural formula, it looks like this. Oxygen O2. One line is one pair of shared electrons. Nitrogen N3. And for group 17, they are all forming one single bond. Like F, single bond F. How come it's a single bond, double bond, or triple bond? Draw the dot and cross diagram and you should be able to find out why. Some other common molecules that you need to know their formulas of are water, ammonia, and methane. So these are formulas that you can't deduce just by looking at the name as compared to, say, sulfur hexafluoride. Okay. Oh, sorry. Last but not least, we look at metals. So metals in metallic bonding, right? We know that they don't exactly lose or gain electrons. It's just that there's metal cations in a sea of delocalized electron. Okay, so the electrons are still there. They didn't formally lose it. It's still there within the entire piece of metal. So the formula is actually the same as that of its chemical symbol. Like magnesium is just Mg. Don't you write Mg2 plus? It exists as Mg because its 2 electrons are not lost. Okay, and then we move on to writing equations. So there are 2 types of equations that you can write. First up is the word equation, which you have learned since secondary 2. So for word equation, we just need to write the substance names. Okay, we say plus, or there's an arrow to indicate that what are the products that it has formed. So whatever's on the left-hand side of the arrow is your reactants, and whatever's on the right-hand side will be your products. So that's all well and good, but then we move on to chemical equations. Okay, what's the point of having chemical equations, and how is it different from word equations? So from word equations, right, you can tell what substance are reacting and what substance are being formed, but you don't know the quantity or the ratio in which they are reacting. Okay, so say hydrogen, oxygen, and water. I've drawn out how they look like, right? So hydrogen is H2, oxygen is O2, and H2O is water. Now, we also learned from, previous scientists that there's this thing called the conservation of mass, which is that no atoms should be created or destroyed in a reaction. The atoms are just rearranged to form new bonds and hence forming new products. So hence we need to balance the chemical equation such that the number of atoms of each element on both sides is the same. So how is this done? If I look at the reaction, so ignore the pink color words first. So there's 2 hydrogen on the left side, 2 oxygen on the left side, but on the right side, let me just write down, H there's 2, O there's 2. On the right side, H there is 2, but O there's only 1. Okay, so these 2 only belongs to hydrogen. So how do I balance the equation? First up, we do exactly this. We write down the number of atoms of each element on each side of the equation. Then I note down what needs to be balanced. Oxygen needs to be changed. How do I do so? I need to multiply the right side by 2. So I put a big 2 in front of the formula of H2O. Now, why don't I just put a 2 behind here? If I put a 2 behind oxygen, I'm actually changing its chemical composition. I'm changing its formula. H2O2 is not water, but H2O2 is hydrogen peroxide. So I'm no longer, talking about the same substance as the word equation already. Therefore, we can never balance a chemical equation by putting subscripts and changing the chemical formula. The only way we can change the number of atoms or ions is by putting coefficients in front of the chemical formula. Okay, so having times 2, hydrogen also times 2, right? So now oxygen will have 2 on each side already, but on the right hand side, I will have 4 hydrogen. On the left hand side, I only have 2. So to balance that, we need to put another 2 in front of H2, such that I end up with 4 hydrogen atoms on each side. Okay, so the steps are exactly as I've said. Then the last step is actually just to check that the final coefficients can't be simplified any further. So sometimes in exam, we see this error that students make, which is that, say, instead of this particular equation, H2 plus O2 gives you H2O. they may have tried many ways to balance it, and they end up with this. 4H2 plus 2O2 gives you 4H2O. So what you notice is that actually we can divide throughout the coefficients by 2. And hence this is not like the lowest common multiple. Oh, sorry. The highest of the... Okay, I can't remember. Is it highest common factor or lowest common multiple? But anyway, it's not simplified lah. Okay? So divide throughout by 2, and you should end up with 2, 1, 2 as the ratio. So this ratio is actually important when we go... So knowing the right chemical formula is important to write a balanced equation. And writing balanced equation is important in mole calculation, which we'll see shortly.